Hello, today I will be recording the network design experiment. So while designing a network, we need to consider a lot of parameters so that we need to make sure that the network is being utilized efficiently or that there is maximum performance in the network. So for the optimum utilization of resources, we need to make sure that each user is assigned a particular set of resources or applications so that he can work comfortably. Also, here we have to make sure that our cost is very minimal. To do all this, we use different configuration objects. Here in this network, we have four different departments that we consider: the engineering, research, sales, and e-commerce. Now here in this, there are two objects, that is the application definition and the profile definition. So in application definition, basically it describes the kind of applications that our network provides. So here if you observe, this is a default application definition that we're using, and this provides 24 different applications, that is database access, email, file transfer, peer-to-peer file sharing, etc. Now in profile definition, we configure the profiles, that is what a node or user is allowed to access, which applications can the user use. So the profile of the user is created using the profile definition object. So here we have the profile definition object. Now according to our subnet, I've created various profiles: engineering profile, the research profile, the e-commerce customer profile, and the salesperson profile. So the engineer here is allowed different applications that he can use. You have configured them as web browsing, light, email, telnet, and file transfer. So basically, the different subnets that are engineering, research, e-commerce, sales are created. They are given different profiles according to which they can access. Now this is my parent subnetwork. Internally, this is an engineering subnetwork. So here I open the engineering subnetwork and I observe that there is a 10-base LAN that I've used, and I've connected this to the Ethernet switch. It is an Ethernet 16 switch, so basically it has 16 ports to connect 16 different nodes. I've used a 10-base link, which is a 10 Mbps twisted pair cable link to connect. Now this is my basic subnet, which is applicable for all engineering, research, e-commerce, and sales. In the server subnet, what I've created are different servers for different types of applications. Like for example, I mentioned that for the engineering profile, I've given HTTP access. So all HTTP packets are sent to the web server. So I've configured the web server, file server, and database server so that web server accesses or handles all the HTTP packets, HTTP light, HTTP heavy packets. The file server handles all the FTP packets, etc. So this is how the basic configuration of the network looks like. And now here I've used LAN modeling. Why LAN modeling? Because it is a much more efficient method, since it requires much less resources. It is more cost efficient, and you can do it once. Like you don't have to do it twice, because I have created profiles, given it to them. I don't have to specifically configure different profiles. So the memory required is also much lesser. So this is my basic simple network scenario. Now I've created another scenario, which is the busy network scenario. So in real life, the thing is that the links that we use for communication are not exactly 100% efficient, or the bandwidth is not 100% utilized. There is a lot of external noise factors which decreases the efficiency of the link. So here it is the same basic subnetwork and network that I've created, same profile definitions. The only difference is that I've changed the link here. So basically, when you click on the link and attributes of the link, you notice that there is a row that I've added here, and here I have set the traffic low to basic 6 bytes per second. So there's an external noise of 6 bytes per second that is added. And the other link is also set to 7 bytes per second. So basically I set some kind of a noise. So basically it won't be full efficiency of the link. And now we will compare these two scenarios to see exactly how the real world works, whereas how the ideal case scenario should work. So the the global attribute that we're going to check here is going to be the page loading result. So we use the HTTP to monitor what is the page response time for both the different scenarios. So I will be comparing the simple network and the busy network scenario. So now we observe. So I will compare this on the basis of time. So I'll make this time average. Now in this you can notice that based on the time in the busy network, for each loading or for response of the packet, it is taking 1.2 seconds, whereas for normal simple network scenario, it is taking minimum of 0.6 seconds. So there is a huge difference in the peaks of both. So basically due to the extra traffic in the network or extra noise in the network, we have more response time for each page, for each request. Thank you.